and class has started. So today in science, we are going to start with that problem.
Yes.
Let's go far back. Ball is dropped from a tower. Hey. Alright, today is 4th March. March 2024, and we're doing physical science, right? We are going to look at I can close this one. Yeah. We are going to look at this problem. Okay, so from the learning guide, the problem is number what? 3-2. It's on page 83. Page 83. Page 83. Exercise 3-1. We are looking at number 4. All right. Try textbook questions. All right. Okay, so we're told that a ball is dropped vertically from a tower, and that the vertical distance covered in the last second equals the distance covered in the first 3 seconds. So I want to show this on the left of the screen and that on the right, and then I also want to make that smaller so I can make this larger so I can also read almost comfortably. Yeah, like that. And here, what did I want to show? I wanted to show the answer. Alright, so ball is dropped vertically from a tower, and then the vertical distance covered in the last second equals the distance covered in the first 3 seconds. You must find the height of the tower. Alright, cool. So we must first consider that the ball covers a total height of initial velocity plus half acceleration due to gravity times 2n minus 1. So let's first ask ourselves questions. What is the 2n minus 1, right? In the nth second, that's the distance that the ball covers. In the nth second. So this is like a general expression for...
So can we get the actual general equation that we're going to find in the exam? Like that we must start with?
Well, it would have to be those ones, the equations of one-dimensional motion. So either back and forth or up and down. And in this case, it's up and down since we're looking at objects that are moving vertically.
So there's no specific equation.
That we can start with to solve this problem.
Yeah.
No, we'll have to make one up within the limits of what we know based on the information that we have.
Can we do that?
I think, yeah, that's what the solution has. So for this one, in the nth second, this is more or less a, so in the nth second, right? This is more or less how we can express the motion of the ball in the y direction. Alright, so u is our initial velocity, which is when the ball gets dropped.
Isn't it similar to this though?
It is, let me see the other one.
Because this is the displacement, right?
Yes.
That's initial velocity. And then we don't
acceleration
have time.
due to gravity.
Acceleration due to gravity. And this, I guess, is time.
This is time, yes. This is time. I just want to understand also where the 2n minus 1 comes from. But let's start off first by analyzing what information we're given. So we're given that the ball starts way up there. And then it gets dropped, right? So ball gets dropped from the top of a tower. So let's say our tower is like that, right? And then it starts off with V initial equals 0 meters per second. And this is H max. This is our total height, H max. Okay, cool. Then the distance it covers in the last second is the same as
the distance it covers
in the first 3 seconds. So t equals 1.
Could it be why they wrote it like that?
That's what I'm trying to get to there. 2n minus 1. So let's look at this different. So we know that our height of the tower will equal what are those equations?
Which equations?
The ones for one-dimensional motion. It's yes, those ones. These are the only general ones that we can get in an exam. But we'll have to be creative with the information to come up with something that can answer the question. So it's V final equals
This
V.
doesn't have to make this so complicated.
So first one is that. Second one is V squared final equals V I squared. Minus what?
You're looking for change in displacement.
This one v squared. Oh yeah, plus 2
2
g
change in displacement.
delta y. Third one is
Change in displacement is equals to initial velocity times time. Change in time. Plus a half multiplied by
acceleration
multiplied by time squared.
change in time squared. And the fourth one?
Displacement is equals to open bracket v initial plus v final over 2.
Like that, right?
Yeah, but the bigger bracket that covers the fraction. Yeah.
Times delta
change in time.
delta t. Okay, cool. So in the first 3 seconds, the displacement is yn. Okay, let's just make it y equals y3. We know its initial velocity was 0, and it's subject to acceleration due to gravity. And we're told that the time is 3 seconds. So if you take 9.8 and we multiply it by 3, how much do we get? If we take let's say we have 9.8 multiplied by 3, it gives us 29.4 meters. Okay. In the last second, we will have okay. So maybe that's the first 3 seconds. Let's just cap it at that, right? The distances are not the same. Wait, the distances are the same, isn't it?
29.4.
The vertical
No,
distance
they
covered
just-
in the last 3 seconds equals the distance covered in the first 3 seconds. Okay. So now we have the distance covered in the first 3 seconds. Okay, but I see why they start off with the distance covered over in the nth second. I just want to understand where this 2n minus 1 could be from and where this equation could be derived from. If we look at displacement equals, is there a formula for displacement equals velocity plus acceleration, half times acceleration multiplied by time? Isn't there a formula like that?
It's similar to this. This is the only one that corresponds to that in the way. Because this does not have half, neither does it have a displacement.
Yes.
This one doesn't have time. This one doesn't have time. Neither does it have. Yeah, it doesn't have time. So if it had time.
Okay. That's fine. Because what I want to establish is, what I would like us to establish is, let me just close that. If we do have a formula that, I think we have a formula like this from grade 11 or grade 10. Let's just look for it.
Something like that.
Yeah.
Displacement is equal to velocity.
I think let's look
Yes.
for that equation, because I think there is such a thing like that. Grade 10 physics learning guide. Mechanics, page 96. Motion in one dimension. Motion in one dimension. Motion in one dimension. Kinematics equation. Okay, so maybe we don't have an equation like that, but hmm. Okay, we don't have this kind of equation. That's not correct, Mr. P. That is not correct. Let's find something more correct.
Would they really bring a question like this into the exam?
I mean, nothing stops them, but doesn't mean we shouldn't want to be creative and challenge ourselves to solve the question.
Yeah, I know. I'm just saying like no. Until I'm trying to figure out would they really, so I can see where I can look for a similar question. That's why I'm asking. Maybe we can look in question papers, something like that, to see if they brought a similar question. And see if we can actually answer from
there, right?
From the memorandum.
Okay. I would have two. I guess you also have question papers. We can scour through previous question papers to find similar ones. Then see if we can't attempt those as well.
Question 3.
Projectiles are always question 3. Okay. I'm drawing a blank. Because what I'm trying to understand is, how would this formula be derived for the time the distance covered in the nth second? Okay, if distance at 1 second would be Distance at 1 second would be vi times 1 plus a half times 9.8 times 1 square, which should be 0 times 1 plus 4.9, which is 4.9 meters. Distance at 2 seconds would be vi times 2 plus a half times 9.8 times 4, which is 2 vi plus 19.6. Okay, is there a common difference? This would be 0, 0.6 meters. Let's see. 2n minus 1 equals 2. Okay, so Joy, check this out, right? When we reverse, okay, I don't know how the 2n plus 1 was exactly derived, but what I can tell you is if we have, since we only know the first 3 seconds and we can estimate the distance more or less with v1 equals 0 meters per second, then t, if t is 2n minus 1, right? At 1 second, the time is 2 times 1 minus 1, which is 1 second. At 2 seconds, it's 2 times 2 minus 1, which is 3 seconds. At t equals 3, it's 6 minus 1, which is 5. Okay, maybe that's also not correct, because I thought it explains that this would give us the first 3 seconds, but it doesn't look like it's giving me that. Doesn't look like it's giving that. Another way to think about this, I don't like why I can't answer this question. I honestly don't.
You think there's a video where they like explain something like this?
I'm not seeing it. That's the other thing. I'm not seeing it. I'm not seeing it. Sure. End the second.
I'm telling you, this man or woman was really angry. Really
When they set
angry.
this one up,
Oh, hungry and angry.
it's
They
all
were
angry. It's all angry.
hungry. And then they decided, you know what, man, I'm gonna give these people stress. And after giving us stress, when they're happy. And this is how this question came about. The person was really angry and irritated. Because it doesn't make sense. This question, it doesn't make sense. Look at the answer. 1, 2, 3. 1, 2, 3 meters. So trust me, the way in.
But there has to be a way this can be made simple enough to explain. Okay, I'm gonna erase all of this. First 3 seconds, ball travels same distance as last second. Same distance as u. But obviously this u equals 0. It's the first velocity, which is v1, vi, which is 0 meters per second.
Okay, so can you ignore this part?
Okay, and look at these ones here.
Look at this one.
The distance covered in the first 3 seconds is 0 plus half gt squared.
Because velocity, the ball was dropped, right?
Yeah.
So it didn't have initial velocity.
It had an initial velocity of magnitude equals 0. Yes.
That's what I mean. There's no initial velocity. It's just...
It is, the initial velocity is 0.
Okay,
Yes.
okay, same. But anyways, then...
So then delta y in 3 seconds would be 0 times a half plus rather half times 9.8 times 3 seconds squared.
Let's say on
is,
our previous Jamboard, on our previous activity when we were doing this, what did we do here? Because we got 29.4.
we used, it was Wednesday science class.
Yeah, it was Wednesday. It's Saturday by that. Okay.
Where do we get 9.8 for delta y?
I think it's on the previous page, right? Because this is the tower that we used. Except the ball was dropped for 3 seconds. Here, we used this formula.
Wait, I think the mistake is to calculate the velocity after a 3 second drop. Because that gave us a 29.4 something.
Yeah, but as well as the formula that we used.
It wasn't correct. We used
The V final is equals to V initial plus acceleration multiplied by time.
Yes, that's the one we used. Okay, so maybe we didn't think about it different by saying in the first 3 seconds how far would it have traveled?
Because we first looked, I think we wanted to look for the velocity first. The final velocity first,
which was
then
not,
which was not doing well.
So that didn't give the correct vibes. Okay. Then now we've got the distance it traveled for the first 3 seconds. And according to the question,
it's bringing back the y-end is equals to velocity multiplied by gravitational force over 2 multiplied by 2n minus 1. It's bringing it back into the equation.
So even though we have the distance traveled in the first 3 seconds, we still don't have a way of explaining or accounting for where does the 2n minus 1 come from, and how, most importantly, was this equation derived. So it must be derived from one of these four equations of motion.
Definitely.
And the answer as to why this formula looks like this is somewhere in the information that we have. So the information that we have is that it's that kinetic energy is half mv squared, so that doesn't count. Velocity equals displacement over time.
We still get 29.4. This becomes our velocity, final velocity.
Let's ignore the final velocity for a while and just look at this issue of the time it takes. So the goal is to determine a general equation of how much the ball drops for any given amount of time. That's where this equation comes from. Okay. So it's a measure of the distance the ball travels, or the displacement the ball travels, for any amount of time. So
let's come up with our own and see if we can get something similar to that.
Because it looks like it's displacement equals velocity initial plus a half g times t. Where can we get this formula? Where is this formula written?
So, there are 2n. 2n minus 1.
A half gt. Yeah, 2n minus 1, yes.
I was going to say let's bring number patterns into this.
Okay, what do you have in mind?
Because it's similar to the Tn is equals to A plus n minus 1 multiplied by D. The structure, I don't know if you...
Okay, so...
The 2n minus 1 just reminds me
of that. That's fine, I don't want to say you're incorrect. What I want to find out is in which formula can we apply that so that it is correct? Because if we can do that, then we'll find how this formula was derived. Since this doesn't look like it's a formula that you can get from any one of the ones we can refer to.
Yeah, so I think we should think outside of physics.
That's fine.
Outside of the physics equations.
That's
and then
okay.
Then absolutely bring in the physics equations. I don't know.
That's fine. Then where do we start with? Like with which equation do we, so that we can get the number pattern that we can derive this from? Or how do you then suggest we start with the whole thing to get something that looks like?
It's not that per se, but remember in number patterns they can give you the first
three terms.
The first, let's say the first and the last term, and then they want you to figure out the terms in between.
That's okay. Now what I want you to explain is where do we start to get that kind of information so that we can guess common difference or constant ratio, etc.
I don't know.
Yes, that's what I want you to.
But Do you get where I'm going?
I get where you're going with this. You want us to find the terms of the sequence, if there is a sequence.
Because the way that I'm putting it here, it makes it seem like it's a sequence because you substitute n, you're gonna get the first time. You substitute
exactly. So
and the second.
It is a series or sequence or whatever. I don't dispute that. It looks like it.
Yeah.
So I'm saying, in order to do a sequence, where can you start so that we get closer and closer to that?
I'm not sure about that.
Yeah, so that's what I want to find out.
Let's open the maths textbook.
Because we normally would substitute with the first term, correct?
Yes. So a ball is shot vertically from a tower.
And we know there t is 0 and velocity is also 0. But it's at h max. And here it's at h0, where we don't know how much time it has passed there, and we also don't know the velocity.
Let's look for the maths textbook.
Right, so
I think we're going somewhere.
That's fine.
I think we're getting somewhere.
T is not known there. Because what I'm inclined to think about from what you just suggested, Gori.
I think I have the equations.
What happens if we take what happens if we take v squared? No, let's okay. Yeah, this problem is a problem, eh?
It is a problem. This is a serious problem.
Yeah.
Because what I think this person did is maths. This one.
I just want to, because the logic is the distance covered in the nth second, right? I think that's where the clue is as well. So the distance that would cover in any second n, but it must be taken from any one of these so that we can get a sequence or whatever. And then that's the general expression. Sure. If we have let's see, what's our function here? Y n equals gt squared. You know that as the ball travels down, the starts off with velocity equals 0. Okay. at 44.1, we don't know the velocity, but we know 3 seconds have passed. What's a half times? So 0.5 times 9.8 times 9. Okay, this takes me back. I want to go back that direction. Let's sheesh. Okay. And then we get what? U plus half gt. And the t. Maybe we can find a sequence for how the time changes. No, wait. Yeah?
For tn is equals to a plus
n minus 1 times d. Yes.
We have a,
it's the first term.
And then we have a plus difference, right?
Yeah, that's the second term.
That's t2, and then it goes on like that.
Okay.
Yeah. But problem would be, we don't know what the last term.
We don't know how many seconds in total the ball drops. Yes.
Yeah, and then that would have been a good idea.
Ball covers the height of yn in the nth second.
No, so what I was thinking was that we find, it's a plus that the difference, then we equate them, and then we try to find the common difference, maybe. Something
we could do that. So maybe let's say we start here. We say at n equals 1 second, then
v initial is
0 times 1 plus a half times 9.8 times 1, which should be 4.9 meters. The second one would be at 2 seconds, would be 0 plus a half times 9.8 times 2 square, which is 19.6, and y3 would be 44.1. So we can find the common difference there, but will it be the same?
I don't know, that's y3.
That's y3, yeah. So 44.1 minus 196 would be, so the difference there will be 24 and a half, and 19.6 minus 4.9. We don't have a common difference. Okay, so we don't have a common difference between the distances. So in fact, as it drops a much longer distance per second as it drops. So this one doesn't really help us. I'm open. There must be another way to find that pattern. I'm still open to suggestion. What other ideas do you think we can come up with?
I think I'm running out of ideas.
You're running out. Okay. I'm also running out of ideas. But there has to be something, yeah.
There should be, like, majority of the time, it's not always one way.
Yeah.
to do it.
There's always
There's an
more than
alternative
one way.
route.
You're right. There's always more than one way to skin a cat, or to
get to town.
To get to town.
Why would you say skin a cat?
That's where the saying. I got the saying from. Pick that up somewhere in the streets, I guess. 2n minus 1. Time takes to travel down would be when you travel down like that, the time always increases in increments of 1 second, right? That's standard. That being said, Captain Obvious, if we're always increasing in 1 second, let me see something. So we've got v squared f 2g delta y 2g delta y. So we don't know what that is, but we know that that's 0. .6. Okay. I also know that Vf is Vi plus gt.
I'm gonna take a question 2 days long.
T. Then that's gonna be 1.8 squared t squared equals y over 1.6. That's
So you see, if it was something like this is a maths question, by the way. Yeah. If it was something like this, okay, so I can't see, and I can't zoom in. Question
3.
The question. Okay, yeah, question 3. If they structured it like this, in a way that we were able to solve it.
Yeah, but like I'm saying, the answer is in the information that we give them. But there has to also be another way that we can also come up with to solve the problem. 4.9 times t squared.
Could be a ratio.
This just gives me that on the previous page. Okay. What we also have here is 2n minus 1.
So it's the last second one.
In the last 1 second of the drop. So let's look at this schematic here. In the last 1 second of the drop, right? The first 3 seconds, the thing drops 44.1 meters. And in the last second, it also drops 44.1 meters. But I wonder if that can't give us information about something. It has to give us information about something. In the last... So on our tower, we basically have something like this, right? It first drops 44.1 meters in 3 seconds, and it also drops 44.1 meters in the last second, 1 second of the drop, before it makes its first bounce at the bottom there. Right. We also have another distance here, which we'll just call y in between. Okay. That equals the distance in the 3 seconds plus the distance in the last 1 second plus, how do we work out that distance? We can have that distance as first, we don't know how much time it takes to travel there in that distance. We also don't know let me see. We don't know how much time it takes to travel there. We also don't know the velocity there. But what is the velocity there? And were we not right to find it using the other equation? We probably were. Let's try that. So that velocity will be...
Could we can find the velocity from here, final velocity here, and initial velocity, but the problem is
we don't know how much time it takes to travel between there and there. We don't know how long that journey is, the distance we don't know. But I think if we can find out the velocity here, then it can be an initial velocity between there and there, but we still wouldn't know what that v is. But if we try and find that velocity there,
also we can use an equation. Which equation?
we can use this one where vi is 0. So it's just gonna be 3 times acceleration due to gravity, which is 21.
24.9. I mean 29.4.
9.8 times 3 is 29.4. Yes. So 29.4 meters per second. We can work with that. So let's say it's 29.4 meters per second. Then that can be our initial velocity there. We don't know the time per se, but we do know this. So let's try that. So we'll say n whatever 29.4 t plus 4.9 t squared. If we take out t, then what's this? Divided by 4.9. What does that give us?
6.
So I'll have 4.9 t into t plus 6. So 4.9 t times t plus 6 will give us this distance there. Then total distance would be that plus, which one did we use to use this one? So this plus mm, 9.8 t squared to 9.4 t plus 4.9 t squared nah, make sure I'm not doing the correct thing here. I'm not doing the correct thing. So if we just have that, this here, so let's have 4.9 t into t plus 6 plus 88.2 2
This question is an enemy of progress.
because now I want to see something, yeah? So I want to Okay, we've got so if we look here, we've got 4.9t squared plus 29.4. So it's yn equals 4.9t squared plus 29.4t plus 88.2. I want to see if we can't use this and then say A is 4.9, B is 29.4, and C is 88.2. So that minus 29.4 plus 29.4 squared minus 4 into 4.9 into 88.2. Just taking a gamble here, but let's just see how far it goes. Minus 29.4 squared minus 4 into 4.9, 88.2, all this over 2 times 4.9. Calculator. And this becomes, let's just say 29.4 squared minus, open bracket, 4 times 4.9 times 88.2 close brackets. I just want to see something. 88.2 times 4.9 times 4 equals, yeesh, minus that plus 29.4 squared. Ooh, delta is negative 86.4, rather 864.36. So we don't have real roots, so this method is not correct.
I got 52.73
For the
positive.
For the positive. Really?
Yeah. I did it bit by bit.
How did you start?
I started off with the root. I started off with this part.
How much did you get for the root alone?
I got for the root I got 50.92.
How did you work it out?
This one, sorry, but this is how I did it.
B squared minus 4AC. Yeah.
I thought I pressed minus.
Excuse. B squared minus 4AC.
And different.
Yeah, so delta, that's why I said it doesn't have real roots. But just because we got that one incorrect doesn't mean
it's incorrect.
We can't, doesn't mean we should just stop here. Ding ding. Hey, which song is that now?
Isn't it for Big Bang Theory?
Oh no, I'm thinking of something else.
I was thinking about the theme song. I think it's Big Bang Theory.
Okay.
And then it starts and then there's a part in
That sounds like those crime scene shows.
It's either that or Friends.
Yeah, I think you're thinking of the other crime scene one. Is it Special Victims Unit, Law and Order? I think that's the way
Maybe.
that one went. But anyway, this problem though, I'm annoyed with it.
Can you Google like YouTube type of
solutions for this type of question?
yeah?
I mean, all I'm interested in is finding out how this monster was derived.
Yeah, maybe we can find someone that can explain to us something like
Joe, we literally just spent the whole